Hi, my name is Ethan Parks. I'll be talking about responsibility-driven design as a way to decide on how to structure your application to improve encapsulation. The inspiration for responsibility-driven design comes from a lot of the drawbacks of data-driven design that we're used to. In data-driven design, your class implementation and definition get too mixed up, so you're defining often the interface of your class to the other classes based on how the class is implemented underneath, and this makes it hard to change the implementation because then you have to change your interface, and then every class that uses that class also has to change. It goes along with it being difficult to modify because everything is so tied together. With responsibility-driven design, our aim is to design classes based on their roles, what they're supposed to be able to do, or what information they're supposed to share, rather than what is going on behind the scenes. Right, so the purpose is to improve encapsulation, because with improved encapsulation we get better code reuse, because each piece of code is divided up based on its responsibility rather than a specific use case. It becomes easier to refine your code because your code isn't all mixed together and isn't dependent on other specific implementations. You can change things under the hood easier. Testing is a lot easier after doing responsibility-driven design because each class has a specific thing it's supposed to be able to do, and you can test each of those individually. Kind of like refining your code, maintaining your code is a lot easier because it's a lot clearer, a lot more clear about what the purpose of each class is, and it's easier to extend on your code because it's easier to realize what the code is already doing, and you can reuse, like we talked about, code to add more functionality. So in the process for responsibility-driven design, you focus on roles and responsibilities for the individual classes and collaborations, so how the classes will work together. And defining these things makes it a lot clearer about what classes should be doing what and how they interact. So here we see an example from the paper which first introduced responsibility-driven design. On the left, we have a raster image class that might be generated by data-driven design, and on the right, we have a raster image class that would be the result of responsibility-driven design. We can see on the left, the raster image class already has the implementation built into it. We already know that we're saving the image in a byte array with an int for the width and an int for the height, and then we get these two functions at the bottom, get byte array and set byte array, that are defined based on how the class was already implemented. Should we change how we want to store or work with this raster image behind the scenes, we'd also have to change these functions. And that means that any class that's relying on this raster image class also has to be updated, which can add a lot of extra time for your code maintenance, refining, and reuse. On the right, we see that we don't define how the raster image is being stored in the implementation, and we only have functions for getting and setting a bounding rectangle around the image, and functions to get the image value at a specific point. This makes it a lot more flexible because we can wait to decide on the implementation until we're actually coding up the solution rather than at the design phase. So responsibility-driven design relies on several constructs: application, object, role, responsibility, and collaboration. These work together to all define your application. An application is just a set of intertwined objects and their object neighborhoods, an object neighborhood being just a set of logically similar objects. So the object is an implementation of a role. A role is just a set of responsibilities that the object is responsible for when it's collaborating with other objects. These collaborations are defined by contracts, which we'll talk about in a little bit. The contracts define how any two objects interact. So responsibility-driven design relies on the client-server model. The client makes requests of the server responds to them. These interactions are defined by a contract. The contract defines what requests the client can make of the server and how the server is required to respond to the client. This cleans up the interactions between classes and allows you to have a clear understanding of what you can get from another class and what a class needs to be able to do. This is all focused on the responsibilities of the class and not the underlying implementation. So we have three types of clients: external, subclass, and self. An external client is what we typically think of, just another class making a request of the server. A subclass client is when a subclass has their server as the superclass. Here they are also uninterested in the implementation in the superclass and make the same kind of request that an external client might make. And the last type of client here is self. So the server should do its best to limit the number of methods that actually do the implementation, so that the other methods can also be not reliant on how the class is being implemented underneath. So in responsibility-driven design, we have role stereotypes, where they're a generalized role that is common to all applications. We give these to objects within our design to help structure what each object is responsible for. So the first role stereotype is controller. A controller is what makes the decisions, and then it uses the upcoming role stereotypes to carry out those decisions. The coordinator role stereotype handles events. This is often things like a command line input or user pressing a button. It receives the event from that and delegates off to the next role stereotype, which is a service provider. Service providers are roles which actually do the work, do the calculations, and update the state of the application. The next type of role stereotype is the information holder. This holds and supplies data. Its role is to provide data to other classes that need it. Then we have the structure role stereotype. It's in charge of relationships between classes and grouping similar classes together. This keeps the classes organized and easier to use for the classes like the service provider or coordinator and controller classes. We then have the interfacer role stereotype. This is a role which just translates between object neighborhoods so that they can all talk together. It creates a clean interface between the groups of nodes so that they can all work together cleanly. So when deciding on what classes should go into your application, the following should be taken into consideration. First, what jobs are being done by your application. Breaking things down into individual jobs provides opportunities to make objects with the service provider role stereotype. What data is being used in going through your application. This is a sign that you would need a information holder stereotype. The next to consider is interfaces to the application. The different interfaces need coordinator stereotypes to handle the input from these interfaces and delegate the jobs down to service providers and information holders. Next thing to consider is what are the decision-making processes going on inside the application. We'll talk about a few different ways to to make those decisions, a few different design patterns about what the best way to make those decisions is. But the signs that you need a decision-making process, or that you need nodes for a decision-making process would show that you need a controller object. Lastly, what kind of groups of objects are you going to end up with in your application, and how are you going to manage those? Those would be a sign that you need a structure object. In responsibility-driven design, we have a concept called control centers. This is the group of classes or single class that are dedicated to making the decisions and coordinating the different service providers to work together to complete the goal of your application. This can be one class or multiple classes, and we will look at a few different designs about what ways you can use control centers to make the decisions in your application. Right, control centers decide how to control and coordinate the classes within your application, and the different control centers have different ideas about where you should place the control. Control centers designs, either we have three types of control center designs: centralized, delegated, and dispersed. As you go down this list, the control gets spread out over more and more classes. We'll see some pros and cons for each of these. So the first design is centralized. We see in the picture the red node is the node making all the decisions, and then communicating all of the decisions down to the service provider nodes. Having one class as your main decision-making node is not the best idea, because it leads to one massive complex class that makes it hard to debug, hard to add on to, just hard to handle in general, because the class gets so big and so complex. It also gets hard to distribute work to a team of developers. This is because just everyone working on the same file leads to a lot of people stepping on each other's toes. You don't have that one defined interface that you're expecting from all the other pieces of code, because you're all within the same interface. So it makes it hard to know what to expect from the code being implemented by other developers. And your service providers can become coupled due to how they're being used in the controller. If the service providers don't really have any control over how they're being used, so if you don't pay attention to it when you're writing this centralized controller, you can end up with high coupling within the service providers. So control centers, the delegated pattern. The decision making is passed on down a short chain of nodes. We can see the red nodes being, again, the controlling nodes. These are where the decisions are being made, and the decisions are kind of being passed down and delegated to more controllers. This means that updating the code is easier, because you have a clear definition of what to expect of the code coming in. You have those contracts between each of the controller nodes, so you know what you can expect to be able to use in the other controllers, and the controllers know what to expect from you when you're calling methods inside them. Also, this pattern is more team friendly. It's a lot easier for people to be working on different files at the same time. You can have a whole team working, maybe one person on each controller, and then you don't get the same toe stepping on that's happening in the centralized design pattern. Decision makers need to know less information. You don't have to have all the information in one controller. The controllers can just pass on what information they need. This helps with information hiding and encapsulation. And you have a clear definition of roles. Instead of one class that just their role is to do everything, you have maybe one to make decisions of type A, and then type B decisions for a different controller. And you can pass down only the relevant information to each of those. So the dispersed control center design, we have just one long chain of red nodes or decision-making nodes. Uh, this can this is uh, not the best design because you get a large call stack to reach information holders. If you're the first node in the chain and you need information from something that's only connected to maybe the last node, you have to go through all of those nodes to get the information from that you need. And this chain of dependencies can break encapsulation. As all of that information is being passed up and down through this chain, you don't really have any more information hiding. And then you lose all of your encapsulation that you were going for as the main goal of responsibility-driven design. Ready to begin mapping out your classes, you can use CRC cards. CRC stands for Candidate Responsibility Collaborators. CRC cards are index cards in which you write the class name at the top, the responsibilities for the class in the column on the left, and the collaborators for each responsibility in a column on the right. When choosing a proper name for your class, it's important to ensure that the name describes the class's role. An example of this would be something like transfer controller in a banking application rather than just naming it controller, which is too generic. Service provider classes should also be given verb names, such as transformer or loader or something like that. Names for classes should last throughout the class's life cycle. A name shouldn't just be something like initializer if the class also lives on after initialization. Class names should only be as specific as needed. You don't need to be so specific that you start describing the implementation underneath. You only need to be specific enough that an outside user of the class can tell what's going on within the class without knowing the specific implementation. So to build these CRC cards, you can begin by running through use cases and building out the classes that you need to handle each use case. So each use case, you can see how the classes that you already have respond to that input or that use case, and see what classes you need to add to be able to handle the new use cases. CRC cards also help you define contracts. You can see the collaborators clearly on the CRC cards, and you can see what responsibilities the collaborators are involved in, and this helps define what the clients of this class as the server expect of the server. You can also use CRC cards to find coupling. If two classes are listed in each other's collaborators column a lot, that means that there's a high coupling between those two classes, and maybe they should be combined, or the overall system should be reevaluated. CRC cards can also help you determine if there are reusable roles. If you see that two classes have similar responsibilities or the same responsibilities, this gives you an opportunity to combine those classes and add some code reuse. Rebecca Werfsbrock, one of the original authors of the paper that first proposed responsibility-driven design, gives a few points that you should be able to hit when finalizing a class and deciding that it should be in your application. The first is you should be able to clearly name the class. You should be able to define its purpose. It shouldn't be ambiguous about what the class is there for. You should be able to stereotype it, which means it should fit into one of those roles that we previously discussed. You should see that it supports at least a single use case, if not more. A class that doesn't support any of the use cases is just an extra class that you can get rid of and cut back on the complexity within your application. You should be able to see how it fits in the overall architecture of your application. You should be able to see you should be able to assign a class one or two initial responsibilities. If you can't assign any responsibilities to a class, then it has no purpose in the application, and you can get rid of it. You should also be able to see how outside classes view this class. This can be through a clear contract. If you have a well-defined contract, you can tell how the outside classes are going to use this class. And you should be able to see how the class behaves differently from other classes. That ensures that it plays a specific role and doesn't provide duplicate functionality. Thank you for listening, and here are the references.